So yeah, I'm Luke Bonaccorsi. I'm a software engineer at Sky Betting and Gaming, and as I've forgotten your name, Gwen. As Gwen said, I run the Leeds community group, and I'm going to be talking about testing with snapshots. So just a quick question: how many of you write code? Just to show of hands. Okay, a fair few. How many of you done stuff with React? Okay, still a few, cool. So a lot of the examples are in React, but I'll talk you through them, so there's no worry about that. So in July 2016, Facebook added snapshot testing to Jest, which is their JS testing framework. And since then, it's become very popular. And you'll probably see as I go through this talk why. But what is it? So you might know it already in the testing world as a visual regression testing. That's sort of a version of it, where you have a website, you take a screenshot of a known good time and it saves it, and that's a good version. And then it's marked with a date, and it's not necessarily marked with a date, but it's marked as a good version. And then later on, when you come and run your tests, it takes another screenshot, and it has differences, that's fine, it compares the two, and because they're different, it fails the test, and it'll show you why they're different, it'll mark it up. And snapshot unit tests are sort of the same, but it's done with code. So you have the tests. When you first run it, it generates the output of a piece of code. It'll save that off, format it in a predictable way, and then save it alongside your tests. You commit it into your source control. And then later on, when you run it again, it will capture the output of that component again, or that piece of code again, format it in the same way so it will always be comparable, and then the two copies are compared, and because they're different in this case, it'll fail. And then it'll tell you what's different with the diff in the command line. And it's pretty damn useful because it speeds everything up so much. You don't have to work out how to access specific things, so if you've got an object, you don't have to figure out how to drill down to find 3 levels deep whether the name is Dave. And you don't have to write a ton of assertions for this is this, this is this, this is this in one object. You can just go, does it match this? Yes, it does. Cool. If it doesn't, that's fair. And when you update it with Jest, you can just pass it a command and it'll update your snapshots. And then you check them. If they're all good, you commit them, and that's that update done. You don't have to go through. It's like, what's the output of this one? Copy paste. What's the output of this one? Copy paste. So let's have a bit of a look at it in action. So this is a basic React component. Can people read that? Cool. So yeah, a basic React component that just renders the header of welcome. And then that's the test for it, that we bring in React, we bring in the component, we bring in a test renderer so that it can actually render the component. And then our test of, does it render the message? We pass the component into the renderer, tell it to convert it to JSON, and then in our expectation, it's just expect that JSON to match the snapshot. And then that's our snapshot. It's just the output, the HTML output of the snapshot, of the component. So it's nice and simple. You verify that. If you're happy with it, then you commit it, and then you've done that test. So with a bit more of a complex example, if you're passing through, for example, properties, it's the same component, but we've just slightly tweaked it. It takes a name and adds it to the message if it exists. And it has the same first test as before because we still want to make sure it works in the same way. But we want to make sure that we can invoke it with a name as well as without a name. So if we pass in name equals Leeds, then it will match that, it'll put that out in the word or in the message. So we've got our two snapshots there. One just saying welcome as we had in the first test, and then one that says welcome Leeds. So nested components. If we had, you don't want to test a component that isn't the one that you're actually looking at. You don't want to test any subcomponents because they should be tested by the component themselves. I hope I've made sense out of that. So this header component shouldn't care about the welcome component. That's a better way of explaining. So we've got a header component now that brings in the welcome component. It just passes it out with welcome, passes in a name if the name's there, and then just says now go away again. And our test for that is we render the header, we have it that we just don't pass anything in because we want to be able to test that it will pass stuff through properly. And then we also render it with the name passed through. So we've got the two examples there. And it does it basically the same, except the difference here is that we have a shallow render. So that means that it will just render one component deep. So it won't actually render out the welcome component. It just goes, here is you invoking the welcome component. This is what you're passing to it if you're passing things through. So that's the snapshot for that. And as you see, the welcome level is just where it's calling the welcome component. It's not actually rendering that out because we don't care about that. And then you see that it also passes through welcome name undefined because it's just passing it straight through because our component doesn't actually care about the name, it just cares to pass it through. And then welcome name Leeds. So we know in both cases it's doing what we're expecting. It's passing through nothing, it's passing through Leeds. And yeah, it's not just for React. It can work on any serializable object. So by that I mean like arrays. So if you had an array, and this is a thing that just takes an array and then reverses any strings to be backwards, because I couldn't think of a simple example of something with an array. So yeah, that's the bit of code that does that reversal. And then in our test, we pull in that method, we have our tests, we call reverse strings with an array that has hello badger 2049, which is a number, not a string, and something else, and then we expect that to match a snapshot. And then in our snapshot, we get hello backwards, badger backwards, 2049 because it's not a string, the right way around, and then something else backwards. So it can work for things that you don't necessarily, it's not just for React. And then you could even use it for API requests. So if you have, this is just a mock endpoint that I made, that if you hit the endpoint loop, you get some information about me. I can't imagine that actually being useful in real life. But yeah, so you make the request, and then you pass that through to the snapshot. So we've got an async one here because it has to make that request. So we just have that done method there that we then just call inside our callback. And all we end up doing is just passing the body through to the snapshot, make sure that we can match that. Then the snapshot is just that because it's passed out as JSON. And that's all the escaping for JSON. But yeah, so it's not a Swiss Army knife. You can't use it for everything. It's useful for a lot of things, so it's more like a screwdriver. You can't test interactions. So if you have button presses and stuff like that, you can't use it for button presses. You need to use actual tests for that. This is more for checking, is the output correct? And then it doesn't work great if there's bits that can change, like dates, unless you're mocking that stuff out. Or if there's other bits that can change just due to other stuff. And without having to dig around a bit and mock stuff out, which is completely possible, it just might be a bit extra work. And because it's not advisable to write snapshots by hand, you can't really do TDD easily, unless you're just constantly updating your snapshots. For me, that's not a huge issue. I don't really do TDD because that's not how my brain works. But yeah, it may be an issue for you. So yeah, why do I like it so much? Well, I was writing a build tool that traversed through scripts, and we end up with one file. And like, how do you test the output of something like that? And I ran the build, checked the output, saved that output, then got it to load that in the tests. And it's basically snapshot testing. And I ended up writing a tool for it. And I don't use Jest for my own stuff because I don't like the framework itself. I use one called Tap. I couldn't find a snapshot testing tool for Tap, so I spent a load of time writing one. I spent like a week and a bit writing one, testing it. And I guess this is where I apologize. Last November, I gave my first real public talk at Leeds JS, and it was talking about automating my house with JavaScript. And I said this, I'm not here to talk about testing. Testing's kind of boring. I ended up writing a testing tool, and I'm now talking at a testing conference, so I guess it's not kind of boring. I guess I just needed to find the right kind of testing. So yeah, that's gone really quickly, but I hope I've given you at least an insight into snapshot testing, and if you've got any questions, give me a shout now.
How sensitive is it to changes in which just come with updates to like your framework? Or can you say, look, we know this bit's going to change constantly, don't even bother about it?
So because of the nature of the snapshot test, it is just this is a point in time. In terms of if stuff changes because of your frameworks, you can just go through and then say update all the snapshots, verify them, and then commit it. So it is still quite sensitive to it, but the update procedure is a lot easier than going through, copying and pasting all the output from the different things and saving it off.
I assume it's very sensitive to the order.
So because it passes it through, so in the Jest example, there's a library called Prissy format that it uses, that it orders things in a certain way and formats it in a certain way so it's predictable, and it'll always pass it through pretty format as it's doing stuff.
So the renderer is sort of pre-ordering between snapshots, so it lines up.
Yeah. So yeah, if you had like a JavaScript object, if the stuff changed, then it would sort that out for you. Anyone else?
I've got a bit of a dumb question.
There's no dumb questions.
What are the primary use cases for this kind of testing?
So the React examples are a great one because you don't want it's rather than you having to go through and dig like, does this have a div? Does this have a span? Does this have all these things? It just takes a snapshot. You can then, as a developer, because you've written the code that generates that, verify that it's correct. If you have a lot more complex cases where you're having to dig, then it can be sort of less beneficial. But if you have, so a great example is if you have a load of permutations based on properties being passed in, that if you pass in a name, then it should render a name component inside this parent component, as well as if you pass in an age, then it should render an age component. You can test all those variations fairly quickly by just snapshotting it and seeing, like, so this is what it should look like with a name, this look like what it should look like with an age, this is what it should look like with both, and stuff like that. Yep.
Right, so take a snapshot of kind of like your DOM elements that's not being rendered. Am I right in thinking that the next time you do a test, it does a comparison of the previous one to the new one, and then fails your test if there is a difference?
Yes.
And so that's how kind of like automation within a DevOps pipeline or within Jenkins or something like that would work.
Yeah, so it doesn't rely on a browser to actually work. In my example side, the React test renderer. Because you have your snapshots committed when you run it on your Jenkins platform, it can render it using that test renderer, and then compare it to your committed version so that it'll pass or fail. If it fails, your build should bomb out.
So how does it then influence velocity and quality of your application? So velocity in terms being quick to market and quality, kind of ensuring that the quality of your code is kind of like adhered to.
So in terms of velocity, because it can increase your rate of actually building tests rather than having to dig through and do the assertions manually of all these items, you can actually get tests out a lot quicker. Your quality, it's as much as people will write tests, because I'd hope because the tests are quicker to write and easier to write, that people would be more willing to write them, so your quality should improve. But it's the same with any tests, where if people don't have the right mindset as they're thinking about it, they'll miss chunks of it out.
I might ask one more question, right? So this sort of really gives some problem with the pink light up there. So in my mind, this seems like a good way of creating a baseline. So if you've got an application that doesn't have any tests at all, I mean, will this allow you to go through and kind of baseline your application to that absolute build that you have in your repo right now, to establish that testing baseline in order for you to move forward from that point?
I'd see it as that it's an easy way of getting at least a start on your tests, especially if it's something like a React code base or stuff where it has an output and you're testing those outputs. I'd see it, it's a quick win sort of thing where you can run it through, test it, and then you've got a basis for other tests to build upon, where you might need more complex things like the interaction testing and stuff like that. Cool. I think that's everything.
Okay, thank you, Luke.
All right.
That was